Hello everyone, my name is Kayla and my honors project is on evaluating the molecular composition of total dissolved organic matter in Baffin Bay through the use of novel proton nuclear magnetic resonance spectroscopy water suppression method. Marine dissolved organic matter, or DOM, is the largest reduced pool of actively cycling carbon in the ocean and is comprised of tens of thousands of different molecules. However, despite its importance, we lack an understanding of its molecular composition. Typically, chemical or size fractionation methods are used to isolate enough salt-free DOM in order to analyze it. However, these methods are biased because they are only able to observe a small subsection of DOM at a time, whereas the method that I have helped develop and am now implementing is able to analyze total seawater DOM pool at once. Using this method, I have been able to determine how the chemical composition of DOM changes with depth, and I have identified the surface distributions of key biomolecules and compound classes throughout Baffin Bay. These samples were collected aboard the Amundsen cruise in 2019, filtered for large particles, poisoned with mercuric chloride, sealed, and transported back to the University of Ottawa, where I was able to prepare them for NMR analysis. To prepare the samples, I centrifuged them to remove residual PON and rigorously clean the NMR tubes before transferring the sample from the ampule into the NMR tube. Finally, the NMR tubes were flame sealed. After running each sample on the Bruker Advanced NMR spectrophotometer for 15 hours and 15 minutes, I then reduced, smoothed, and normalized the resulting data so that it could be used for calculations. I calculated the percent relative abundance for the major compound classes based on known chemical shifts of proton functional groups, and also performed a principal component analysis to determine the compound classes that can explain the most variance in compounds across all spectra in the data set. I first did this for the depth profile at the deepest and most central station in Baffin Bay. From the top graph, you can see that there is an abundance of CHO carbohydrates is high in the surface water, but decreases with depth. Whereas in the bottom graph, there is a mirrored image that shows that carboxylic-rich alicyclic molecules, also known as CRAM, is low in abundance in the surface water and then increases with depth. This is likely because in the surface water, there is an abundance of primary producers that produce CHO carbohydrates, whereas in the deep water, there are very few primary producers, but heterotrophic bacteria have had more time to consume these bioavailable carbohydrates and release CRAM as a degradation product, thus explaining the reduction in CHO carbohydrates and the increase in CRAM at depth. It's interesting to note that for the deepest station at 2,300 meters, the CRAM abundance suddenly drops and the CHO carbohydrate abundance suddenly increases. This is likely due to the resuspension of particulate organic matter from the benthic nephloid layer that is extracellularly enzymatically hydrolyzed by deep bacteria into the CHO carbohydrate. I also applied this method to analyze the changing DOM in the surface water of Baffin Bay and found patterns that followed two major current systems, the Baffin Island current and the Western Greenland current. As the currents travel along their respective coastlines, the abundance of CH3-deoxy sugar, methane thiol, and N-acetylamino sugar all increase in abundance, whereas the CHO carbohydrates decrease in abundance. This is likely because towards the end of the currents, where the water has had more time to travel, the bacteria in the water have also had more time to consume the CHO carbohydrates, thus reducing its abundance. Similarly, these bacteria have also had time to release CH3-deoxy sugar, methane thiol, and N-acetylamino sugar as degradation products, thus increasing their abundance. One station which does not follow this trend is BB18, which is located in a fjord off the coast of Greenland. This station has an abundance of phytoplankton in the surface water, which is indicated by the high fluorescence value. When phytoplankton become overradiated, they release excess CHO carbohydrates as a degradation product, which explains the spike in CHO carbohydrates abundance at this site. Moving forward, I plan to calculate the DOC concentrations as well as use 2D correlation analysis to further analyze the changes in DOM abundance throughout Baffin Bay. Finally, I want to say a special thank you to my supervisor, Dr. Brett Walker, and everyone else who has helped me out along the way. Thank you.